Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 2 of Networking Fundamentals, and in this video, we will deep dive into the concept called OSI model. Before we do that, let's quickly recap what we have learned as part of episode 1. In episode 1, we learned about IP address, what exactly is a subnet, what are the different types of subnets. We learned about CIDR, how to read, write, and perform calculations on CIDR blocks. If you are not aware of these networking basics, I'll highly recommend you to watch episode 1, and the link to episode 1 is in the description. Now let's move towards the whiteboard and start understanding the concept for today, that is OSI model. We all interact with servers on a day-to-day basis. Let's take a simple example. Let's say I open my laptop, open one of my favorite browsers, and search for google.com. Within a fraction of seconds, I receive a response back, which is nothing but Google homepage, a HTML page, basically. But how does this thing happen? How is my request from my personal laptop sent over the internet to one of these Google servers? And how is the response received back to my personal laptop? What are the different components that are involved? And what are the different layers in which the journey of data takes place? So I'm calling it as journey of data because whatever you are trying to request and whatever you are trying to send is all data. So OSI model is one of the popular models that helps you understand the journey of data across the internet. What are the different layers that are involved? And OSI model explains this entire thing in 7 layers. Layer 7 to layer 1. Sometimes it can be layer 1 to layer 7 if you are at the receiving end of the data. But what exactly each of these layers do? What happens to my data in each of these layers? When I say layer 7, layer 6, layer 5, layer 4, layer 3, 2, and 1, what each of these layers actually do? How my data gets transformed in each of these layers, and finally, how does it reach one of these Google servers? Let's try to understand the same thing in today's video. We will use the same example, that is request to google.com, and let's try to understand the complete workflow here. Before we understand the journey of data, that is, even before your browser initiates a request to the Google server, there are two things that happens. That is, even before the OSI model comes into picture, they are: number one is DNS resolution. It is also good to understand these concepts before you understand the OSI model and what each and every layer does, because this is also part of the entire workflow that you are trying to learn, the networking concepts. DNS resolution, and the second thing that happens is the TCP handshake. Now, why these things happens even before your request is initiated, right? Even before the request starts or even before the request is sent, why these things happens? Because let's say you are searching for, or you are trying to make a request to https www.google.com. First of all, what your router, that is your home router or your browser, tries to do is they will try to verify if www.google.com is mapped to any particular IP address. So there is a system called DNS, which is nothing but domain naming service. You can understand it as a simple database, right? Just try to understand it as simple database where records are maintained, right? If I have to explain this in a very simple way, just try to understand that every router has this information, which is records of domain name mapping with IP address, right? So when you are saying www.google.com, in this domain naming service, there is an IP address against the google.com domain name. Now, when you search for this www.google.com, router verifies this initially in the local cache, right? Just like your laptop has a local cache, or you have the local memory. Similarly, your router initially searches this for in the local cache, where previously if your router has made a request to this particular website, it might have maintained its records in the local cache. If this information is not available in the local cache, then it goes to your internet service provider and verifies this particular mapping, if there is any mapping for the domain name in your internet service provider's DNS. Every internet service provider maintains a DNS where the complete records are available, right? So google.com is usually mapped to the IP address 8.8.8.8. So if this mapping happens, if this domain that you're trying to reach is actually valid, only then you will move to the second stage. Why this needs to be performed? Because let's say I'm trying to access something like www.Abhishek.Veeramalla.com. Now, this is something that does not even exist. I did not create this domain. I did not map it to a particular IP address. Now, what's the point of starting with this entire data journey? Sometimes you might be uploading some 10 GB file, or you might be sending a huge amount of data. Now, if the DNS itself is not resolved, what's the point of even starting the data journey, or what's the point of even initiating the request? Why should your browser or router initiate a request, right? So this is the first step that happens, DNS resolution. If the DNS resolution happens, then comes your second stage, which is nothing but TCP handshake. Now, what is the TCP handshake? Again, it's a very simple concept. Let's say this is your laptop and this is the Google server. Now, you are trying to send a request to it. You are ready to send a request, but is the server that you're trying to send is ready to accept your request? What if it denies your request even after sending this entire thing, right? What if you cannot make a handshake with it? Handshake is nothing but you are just trying to say hi and it says, hi, I'm okay to accept your request. So there is a TCP handshake, which is usually called as a three-way handshake, that gets performed even before your request initiation or even before your OSI model comes into picture. Now, how does this three-way handshake perform? So when you say www.google.com, what your router or browser, what they try to do is they initially send a hi to the server. Like, let's say this is your laptop and this is your server. So initially, the router tries to send a hi. In networking terminology, we call it as sync. And if this server is ready to accept, if it says that, okay, I'm good, then it says hi, which is in the networking terminology, sync acknowledged. And finally, your laptop says acknowledged. So this happens in 3 steps. That's why we call it as a three-way handshake. Now you might ask me, but Abhishek, why can't it be very simple as you say sync and it says sync acknowledged and it's done? So it's a very detailed explanation. Let's not go into it. But if you are interested, there is also something called two-way handshake. And there's also something called four-way handshake. So if you are interested, you can go through these things. You can read about difference between two-way, three-way, and four-way handshake. Three-way is the most popular and which is mostly used. So that's why I'm talking about the three-way handshake, but you can also read about these things. So these are the two you can consider as prerequisites even before your data request initiation takes place. One is DNS resolution. Two is the TCP handshake. Now that you understand both of these concepts, that is, if DNS resolution is done and TCP handshake is also done, then your data initiation or your data request initiation starts. Now let's try to understand that in terms of the OSI model. Now, I hope you understood why did I explain this even before the OSI model, because when you are learning networking, it's important to understand the end-to-end part of it. Now to start with OSI model, let's take same example. When you search HTTPS www.google.com, and I'm assuming DNS resolution is successful and TCP handshake is successful. So what happens after that is your browser, right? Understand this carefully. Your browser initiates a HTTP or HTTPS request to the server. That is this one, right? So you are searching for google.com in the browser. So your browser is initiating a request now. It did not send the request, but the initial process has started. Now, when the initial process has started, it says use HTTP based request. Why? Because you have asked for it. Let's say you're asking for FTP, then your browser initiates a FTP based request, right? So this particular stage is called as layer 7, which is the initial stage and also called as application layer. In this particular layer, you can pass some headers, right? And you can also provide information for the authentication or whatever is required, but this happens in the layer 7. Then comes like once your browser has initiated the HTTP request, right? If I go back to this particular thing, once the request is initiated, now what should be the next step? If you think about it, the next step should be data encryption, right? Because no one in the entire process, like from your laptop to the server, data goes through multiple routers. I'll talk about it. What are these routers? But basically, data first goes to your home router, then it goes to your internet service provider. From them, it goes to a different router, and finally it goes to the Google server. So if your data is encrypted, then even if someone tries to hack your data, they don't understand what exactly it is. And that's where we use HTTPS, right? So when you use HTTPS, the next step that has to happen after the HTTP request initiation is data encryption, which is also called as data formatting. And this layer in OSI model is called as layer 6, which is also called as presentation layer. Now, all of these layers are virtual just for you to understand. So OSI model is trying to just explain you that, okay, this is the first step that happens. This is the second step that happens. And once HTTP request is made, data is encrypted. What should be the next step? The next step should be your browser should create a session. What exactly this is? Very simple. Let's say today you can go to facebook.com and probably search for facebook.com/Abhishek.Veeramalla. 20 minutes later, take a different tab or probably take a different window as well and search for facebook.com/Raju or John. Your browser will not ask you to authenticate one more time. Initially, when you search for facebook.com/Abhishek.Veeramalla, it will ask you to log in into Facebook. But even after 20 minutes, if you search for /John or /XYZ, facebook.com does not ask you to authenticate because there is a session that is maintained. And this session is very, very important because sometimes, let's take example of your banking transaction. Okay. So initially you log into your bank and probably you try to send someone some amount or, you try to make a transaction. What if your session gets disconnected in 1 minute? You just have 1 minute you complete your transaction, or you make a transaction and you want to make one more transaction, right? Unless you log out, your bank server should not ask you to log in one more time. And that happens only if your browser creates a session. We all use sessions on a day-to-day basis. Whether you are using Instagram, Facebook, or anything, there are sessions that are maintained. So once the HTTP request is initiated, second thing that happens is encryption, which is nothing but data formatting in the presentation layer. And then a session is created with you and the server So that the server does not ask you to authenticate multiple times. And this particular thing is called as session layer. And one interesting thing about all these three layers, right? Layer 7, layer 6, and layer 5 is that all of these three layers are maintained by your browser, right? So all these three layers happen at your browser level. What does that mean? Let's say you're using Chrome or you're using Firefox or you're using any particular browser. Layer 7, layer 6, and layer 5 are taken care by those browsers itself, right? Your browser initiates a request, then your browser, depending upon HTTPS and what kind of certificates that you're providing, it takes care of encryption, and your browser only takes care of session. If you want an example, just go to your browser, go to your browser settings, and try to clear cache as well as cookies, and then try to authenticate with the facebook.com. Let's say you authenticated facebook.com. 2 minutes later, if you delete the cookies and cache, it will ask you to authenticate one more time because you have deleted the session. Session is basically stored in cookies and cache, right? So layer 7, 6, and 5 are taken care by your browser itself. We did not even come to the router part. If this is my laptop and this is my server, laptop is connected to my home router. Till now, whatever I discussed is happening in the browser itself. My request even did not reach this particular browser if I'm talking about only layer 6, 5, and 4. Now, the next thing that happens is once the session is also created to transmit the data, right? If we are taking this example, some cases, the data that you're transmitting can be of 10 GB also, right? Probably you're trying to upload a movie or you're trying to do something. So if you are trying to do data in one at a time, like if 10 GB if you're trying to upload it once, or even simple things such as requesting to google.com, what usually happens is your data is segmented, right? That is the data that you're trying to send or the data that you're trying to receive is segmented and split into parts. So this particular thing is called as segmentation, and this happens in layer 4. Along with the segmentation, in this particular layer, the protocol is also defined, whether you want to use TCP or UDP, right? So there are only two protocols which are like these are the widely used, TCP as well as UDP. And in layer 4, once all of these things happen, data segmentation takes place and the particular protocol is also identified in this layer. How is the protocol identified? Mostly these are standardized. Let's say if you're using HTTP, the protocol is TCP. If you're using something like DNS or something else, the protocol is UDP. So these protocols are standardized, and if you are using HTTP, TCP is the protocol that is used to transmit the data from here on. That is, the segments of data that got split are transmitted using the TCP protocol. And this layer is called as transport layer. Now, once the data segmentation is also done, now it's time to send the data. And to send the data, the first thing that happens is the data that's sent is received by your router. And what your router does is router does two particular things. One is to this segmented data. Let's say you want to travel from Delhi to Mumbai. Here you know what is your destination, right? You know that you want to travel from Delhi to Mumbai. And second thing is what is the shortest path. Probably you can travel from Delhi to Mumbai in 20 different ways, but you will only pick up the shortest path. Similarly, even in this example, data from your personal laptop to google.com, that is from India to the US, there will be multiple hops for your data. That is, there are multiple routers that are involved. Probably your home router, then your internet service provider, from your internet service provider, to etc, etc, XYZ, and finally it reaches the Google server. So which routers or which hops should your data take to reach the Google server in the fastest way? To understand that, what we will do in the layer 3 is that we will add source IP address as well as destination IP address to each segment, right? And here, once you add the source IP address and the destination IP address, we call this data as packets, right? So packets have a clear information of how to travel, which path to take, and who takes this decision. This decision is taken by your router. And this layer is called as networking layer. Just try to take this example. Delhi to Mumbai, if you have to travel, you need to know what is your source and what is your destination. If you want to send 100 people from Delhi to Mumbai, to each and every person, you will tell them that, okay, this is the path that you have to take. Similarly, in layer 3, your router comes into picture and your router tells each and every packet that, okay, this is the source, this is the destination IP address, and you need to travel through these hops, right? And this layer is called as networking layer. Then comes your layer 2. And in layer 2, like, okay, now your router received the information. But if you understand it carefully, usually these routers are connected to switches, right? Even if you look at your home network, your router is connected to an Ethernet port. And from the Ethernet port, your router is connected to the cables, right? So if you're talking about these Ethernet ports, or if you're talking about these switches, right? Now data has to be sent some or the other time to these Ethernet ports or to these switches, right? So at this point of time, when the data has to be sent to the Ethernet ports, the data has to be transformed from the packets to frames, depending upon the medium that you're using. If you are using router, the data is converted into packets. Then if you are using these switches, the data is converted into frames. And in these frames, along with this IP address that you have provided, MAC information is also added, which is nothing but MAC information tells these switches what are the other components within your network, right? So here MAC components are also added. Now you might be thinking, but why can't I use packets? Because your medium has changed. From router, this request is being sent to switches, and switches only understands how data can be transmitted in the frames. So this layer is called as data link layer. Finally, you have layer 1, that is your data end of the day, or your router switches end of the day are connected to optical cables. And guess what language these optical cables understand? The language these optical cable understands is electronic signals, right? So here your data is transmitted into electronic signals, and using optical cables, data is transmitted very fast, right? And this is how your data is transformed, right? If I have to explain this in one single slide one more time, you have layer 7, layer 6, layer 5, layer 4, 3, 2, and 1. So if you take your personal laptop and this is your Google server, for example. Now, when you initiate a request to www.google.com, so initially what your browser does starts with layer 7. I mean, the process starts with layer 7, where first of all, it defines what is the type of request. So mostly we use HTTP type request. So HTTP or HTTPS. Now, once it identifies that, okay, I have to initiate a HTTP based request, second thing that it does in the layer 6 is encrypt the data. Once the data is also encrypted, the next thing that happens is create a session with the server. Now, once the session is created with the server, because data has to be transmitted within fraction of seconds, segmentation of data is important. And that happens in layer 4. And here, along with the segmentation, the protocol is also identified, depending upon the request that you are making. If it is HTTP, TCP request is most widely used. Once the segmentation is also done, right? Now the data is divided into small parts. After that, data reaches your routers, and within the routers, the path to transmit the data is identified, because in this layer we add the IP address for each and every segment, and here we call them as packets. Once packets are also created, then the next thing is, from the routers you will move towards the switches, and here data is converted into frames, where you add the MAC address of each and every component that is there, so that you know like you add the MAC address so that within the network this switch can understand what are the other components to transmit the data. And finally, layer 1 is a physical layer where these switches are connected to optical cables, and here the data is converted to electric signals or electronic signals, whatever you would like to call it, right? So when you initiated the request from layer 7, layer 6, 5, 4, 3, 2, 1, what happened? From your laptop, it went to your router. From router, it went to switch, and it connected to the cable. Now it goes through multiple hops over the internet, and finally it will reach one of these Google servers, right? From layer 1, which is, let's say this is one of the cables, then it is connected to other routers, other switch, and again cable. And this entire thing happens, and the data is transmitted, and finally it reaches one of these Google servers. Now understand carefully what happens here. When this data received by one of these Google servers, again the OSI model comes into picture, where initially data is received by one of these Google physical servers. So one of these Google physical servers is connected to an optical cable. So L1. From there, it will go to one of the switchboards. Then it identifies which router to use. From there, the data which you have been using as packets, like whether it's a TCP or UDP, right? Let's say we are using the TCP protocol. So here the TCP data is taken into place. From there, once you have the TCP data here, then session is validated. After that, de-encryption takes place. From there, it will go to one of the Google's applications, and this Google application will say, hey, okay, this is your request, so let me give you a HTML page as a response back. Here, this application is a microservice or any particular monolithic application which has the source code, and it understands, depending upon your request, okay, I want to generate a HTML page. Now again, this HTML page is sent back to your personal laptop, and same thing happens, right? Before it reaches your personal laptop, your router is connected to a physical cable, so it has to move from L1, L2, L3, L4, 5, 6, and finally reach your particular laptop. So this is the entire OSI model. And basically, when you are sending the request, L7 to L1 data is transmitted, right? Data is transmitted through L7 to L1 layers. Now, when you are at the receiving end, data is received from layer 1 to layer 7. So these are not the physical layers, right? These are just a way of explanation of OSI model. For you to understand the data transmission in a better way, OSI model explains it in this particular way. Of course, OSI model is not the latest model. There are models like TCPIP model, right? Which is again based on OSI model. But the thing is, in TCP/IP model, L7, L6, L5 is combined, because more or less these are performed by the same component, that is your browser. So L7, L6, and L5 are combined and called as a single layer in the TCP/IP model. So why people usually prefer OSI model? Because this is a standard, and if you understand this standard, you typically understand the entire transmission of data. Whether it's TCP/IP model or any new model, they are all based on the OSI model, right? So don't get confused. If you see TCP/IP model, it's exactly the same. Only difference is L7, L6, and L5 are combined, and usually they are called as one single layer in the TCP/IP model, right? So this is the video for today, and how this OSI model is helpful for the DevOps engineers. I will tell you that it is not completely must-have thing, right? This knowledge is kind of a good to have thing. I'll tell you the reason why. Because these days, all of these things is standardized and this entire thing is completely automated. Like you won't see anyone using Wireshark these days unless you are working in the core networking company, and probably if you are dealing with the layer 3, layer 2, or if you are involved in any sort of networking companies, only then you see people using these kind of things, right? The Wireshark or any tools to decrypt the packets, understand this thing. But if you have a high level knowledge of OSI model, that is more than enough. You don't have to dig dive and try to understand what are the different protocols in layer 3, right? You don't have to understand what are the different types of techniques that are available in layer 2, because this is an ocean, and whatever I taught in this particular video, it's more than enough if you are trying to understand networking as a DevOps engineer. Thank you so much for watching today's video. See you all in the next one. Bye bye.